Welcome back to Simplified Chemistry. In this video, I'm going to cover the topic on amount of substance. I'm focusing on calculating mass. By the end of this video, you should be able to calculate the mass of either the reactants or products from a balanced equation. Here is the first example. Calculate the mass of calcium oxide obtained by heating 10 grams of limestone, which means the same as calcium carbonate. To work out the mass of calcium oxide, follow these basic simple steps. Step 1. Write a chemical equation that is balanced. Here I'm showing you a balanced chemical equation. When 1 mole of calcium carbonate is heated, it gives 1 mole of calcium oxide and 1 mole of carbon dioxide. In chemistry, if you have a balanced chemical equation and there's no number in front of the reactants or the products, you can assume that the number in front of this reactant or product is 1. In this example, I am going to ignore carbon dioxide because it's irrelevant to the question. We only asked about calcium oxide. So here I'm showing you that 1 mole of calcium carbonate gives 1 mole of calcium oxide. The next step is to convert the moles into molecular weight. I've covered the topic of calculating molecular weights in a separate video. If you'd like to recap on this topic, click on the link below. Based on the calculations, we know that 100 grams of calcium carbonate give 56 grams of calcium oxide. We can use simple proportions to work out the amount of calcium oxide produced when 10 grams of limestone is heated. First, start by working out how much only 1 gram of calcium carbonate would give you. To get this value, divide 56 by 100, and this gives us 0.56 grams of calcium oxide. If 1 gram of calcium carbonate gives us 0.56 grams of calcium oxide, then 10 grams of calcium oxide will give us 10 times the amount of calcium oxide, and this is equivalent to 5.6 grams of calcium oxide. Here is a second example. In this example, we have to calculate the amount of oxygen that is produced when 1.47 grams of potassium chloride decomposes. We have a chemical equation showing the decomposition of potassium chloride. In this equation, we see 2 moles of potassium chloride decomposes to give 2 moles of potassium chloride and 3 moles of oxygen. I'm going to ignore potassium chloride because it's not relevant to this question. 2 moles of potassium chloride decompose to give 3 moles of oxygen. In the next step, we convert the number of moles into molecular weight. And the molecular weight of potassium chloride is 122.55. We multiply this by 2 because we have 2 moles, and this gives us 245.1 grams. The molecular weight of oxygen is 32. We multiply this by 3 because we have 3 moles, and this gives 96. From the molecular weights, we can see that 245.1 grams of potassium chloride decomposes to give 96 grams of oxygen. Divide 96 by 245.1 to work out the amount of oxygen that is produced when only 1 gram of potassium chloride decomposes, and this gives 0.392 grams of oxygen. By using simple proportions, if 1 gram of potassium chloride gives 0.92 grams of oxygen, then 1.47 grams of potassium chloride will give 0.392 times 1.47 grams of oxygen, which is equivalent to 0.576 grams of oxygen.